Today we will discuss about the apparent change in the weight of the body lying in the lift, which is in the motion. Before proceeding, we need to recall Newton's second law of motion. So, what is Newton's second law of motion? When any force is applied on a body which is free to move, when any force is applied on a body, then an acceleration is produced in the body in the direction of applied force. The produced acceleration is directly proportional to the force applied and inversely proportional to the mass of the body. So, finally, we get F is equal to ma. Remember, F is net force over here, and the motion of body takes place always along the net force. This is the first thing. And second thing which you need to remember is the apparent weight. Apparent weight is always equal to the normal reaction of the body. Remember these two things before proceeding further. So first case is when lift is moving upwards with constant velocity. So suppose any object of mass small m is placed in the lift. So first of all, weight mg will act in downward direction and the normal reaction n will be in upward direction, and lift is moving upward with v square to constant. So first of all, we need to determine net upward force acting on the body. As lift is moving upwards, therefore net upward force acting on the body and that must be equal to ma. And what should be a? A is acceleration. So net upward force, it should be upward force minus downward force. It must be equal to ma. Upward force, we can see it is capital N and downward force is mg. It will be equal to ma. But there is a problem. Since lift is moving with constant velocity, since v is equal to constant, therefore a is equal to dv by dt, that is the rate of change of velocity, will be 0. So we can say n minus mg, it will be equal to 0. So we can see n is equal to mg as there is no, we can see normal reaction is exactly equal to the weight of the body, so there will not be any change in the weight of the body if the lift is moving upwards with constant velocity. Similar case will happen with the situation when the lift is moving downwards with constant velocity. So again, weight will act in downward direction, normal reaction n in upward direction, and lift is moving downwards with v square to constant. Let us discuss. As the lift is moving downwards with the constant velocity, so as lift is going downwards with the constant velocity, therefore net downward force on the body. Remember, net force is always equal to ma, so again write it as ma. Net downward force means downward force minus upward force is equal to ma. Downward force is mg, upward force is n, equal to ma. Again, since v is equal to constant, therefore a is equal to 0, so you will get mg minus n is equal to 0 or n is equal to mg. So you can see again there is no change in weight of the body if the lift is moving with the constant velocity. But what will happen if the lift moves with some acceleration? Consider a case when lift is moving upwards with constant acceleration. So here suppose there is a body and lift is moving upwards with constant acceleration. So draw the forces acting on the body. First of all, weight mg will act in downward direction and the normal reaction n will be in upward direction. So as we know that lift is moving upwards, so we need to discuss net upward force. Net upward force on the body, and it must be equal to ma. Upward force, as we need to determine net upward force, that means upward force minus downward force must be equal to ma. Upward force, it is clearly capital N and downward force is mg, so we can see it is ma. So we can say n is equal to mg plus ma or m times g plus a. As we can see, something has been added in the weight of the body. Mg is the weight, the natural weight, and ma is the force which has been added in mg. So we can say if the lift is moving upwards with some acceleration, then definitely the apparent weight of the body will increase. Now think, if the lift moves downward with some acceleration, downwards with acceleration, constant acceleration. This is the body, draw the forces mg and in upward direction. So as the lift is moving downwards, so net downward force, net downward force acting on the body, it must be ma. Downward force, as we are determining the net downward force, so downward force minus upward force must be equal to ma. Downward force, we can see it is mg, upward force is n, it is equal to ma, so you will get n is equal to mg minus ma or mg minus a. Now you can see something has been subtracted from the weight of the body, that is ma has been subtracted from the weight of the body. As you have subtracted something from the weight of the body, it means the apparent weight of the body will get decreased. It is not necessary that every time lift moves with acceleration, it can move with some retardation. So what will happen if the lift moves upward with constant retardation? Let us see. This is the body and lift is moving with some retardation. Retardation means negative acceleration. Again, weight mg will act in downward direction and will act in upward direction. So what will happen? Lift is moving upwards, so net upward force, net upward force on the body or acting on the body it will be equal to m into minus a, because acceleration is negative, that is retardation. So we can say, as it is net upward force, we can say it will be upward force minus downward force is equal to minus ma. What is upward force over here? It is capital N. Downward force is mg minus ma. So we can say N is equal to mg minus ma or mg minus a. Oh, you can see, even when lift is moving upwards, lift is going upwards, if still the weight is decreasing. So if the lift moves upward with retardation, the weight, apparent weight, will get decreased. That is, weight of the body will appear to be decreased. Now think the case when lift moves down, lift goes down with constant retardation. And lift is going downwards with constant retardation. Again, you can draw the forces, that is weight mg in downward direction, normal reaction n in upward direction. So as lift is moving downwards, so we can say net downward force on the body, it will be equal to m into minus a, as retardation it is. Downward force minus upward force will provide net downward force, that must be equal to minus ma. Downward force is mg, upward force is n, so it is minus ma. So you can see n is equal to mg plus ma, or you may say the apparent weight is going to increase. And when it is going to increase? When lift is moving downwards but with some retardation. All that which you had learned over here, yet it is just mathematics. But what is the physics? What is the physics behind the change in weight, apparent change in weight? So consider a case when lift is going upwards. When lift goes upwards with some acceleration, what happens? First of all, draw the forces, weight mg in downward direction, normal reaction in upward direction. What happens? Lift is accelerating. It means continuously the speed of lift is increasing, but due to the inertia, the object lying in the lift will have tendency to maintain the previous speed, whatsoever it will have. So what happens? Lift will exert a force on the body in upward direction to let it gain some speed, as it will be some action. So as a result, this object will exert a force on the lift as a reactionary force. So you can understand, in that situation, suppose the object is placed on the weighing machine. So on weighing machine, one force mg will be acting, and another reactionary force. This reactionary force will also start acting on the body, on the weighing machine. So you can see two forces will act on the weighing machine when lift is going upwards with some acceleration. So what can you see? Weighing machine will start showing greater weight as compared to the previous situation, that is the original weight. So apparent weight will get increased. You can think about other cases in the similar manner. Thank you so much.